Good afternoon, students. Now I'm teaching CBSE grade 10 chapter 1 real numbers exercise 1.1. In previous videos I am explained exercise 1.1 1 2 find SCF by using Euclid division lemma. Okay, that problems. Now third one. Here an army contingent of 616 members is to march behind an army band of 32 members in a parade. Okay, so the two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? Okay, how we can find this one? By using Euclid division lemma. Maximum number of, that means you can find HCF. Okay, so yeah, by using Euclid division lemma, Euclid division lemma. So here 616 divided by 32. Okay, 32 1 ja 32. Here 6. From 1 we cannot subtract 2. Take the borrow 11 9. Here 6. Here 5 5 2. From 5 we can subtract 3. We can get as 2. So next 32 8 ja. That is 8 2 ja 16. 8 3 ja 24 plus 1 25. So next 0 4. Again 32 9 ja 9 2 ja now 18. Next 9 3 ja 27 plus 1 28. So from 6 we cannot subtract 8. Take the borrow. So from 16 we can 8 subtract, that is 8. 8 is divided by 32. 8 4 ja 32. So the remainder is how much? 0. So what is the SCF of 616 and 32? 8. Okay, by using Euclid division lemma, A is equal B into Q plus R. The remainder condition is it is greater than or equal 0 and less than the divisor. So that is here 0 less than or less than B. So here how many times you can use the Euclid division lemma? 1, 2. Okay, so that is here A 616 is equal 32 into 9D plus remainder is 8. So next 32 is equal 8 into 4 plus 0. So the where we can get the remainder 0 at the divisor 8. That means how many groups, how many columns we can make with 616 members is to march and 32 members in a parade. That is how many groups? 8. In exercise 1.1, I am already explained the remaining problems last previous videos. Now I explain example 5. So consider the number 4 power n where n is a natural number. Check whether there is any value of n for which 4 power n ends with a digit 0. Here we know that any number it is end with the digit 0. It is multiples of 2 and 5. That means the number is divisible by 2 and 5. That means the number is divisible by 10. So what the division by 10 rule? A number which is divided by 10, its unit digit is 0. Or it is divisible by 2 and 5. That means the number which is multiples of 2 and 5, then the number is end with the digit 0. So here consider the number 4 power n where n is a natural number. Check whether there is any value of n for which 4 power n ends with the digit 0. If it is end with the digit 0, the number 4 power n is multiples of 2 and 5. So that number, its prime factorization is 2 and 5. Okay, so here given a number 4 power n for all n is a natural number. N is a natural number. If n is equal to 1, then 4 power 1 is equal to 4. If n is equal to 1, then 4 power n is end with the digit 4. So 4 how we can write? 2 into 2. Its prime factorization is 2 only. Next n is equal to 2. That is 4 square. That is how much? 16. So the number 4 power n is end with the digit 6 if n is equal to 2. Okay, so 16 how we can write? 2 into 2 into 2 into 2. So its prime factorization is 2 square. Here we can write as 2 power 4. Okay, here it is end with the digit 4. Here it is end with the digit 6. Next n is equal to 3. So then 4 cube. So that is 4 into 4 into 4. 4 4 ja 16, 16 4 ja 64. So it is end with the digit 4. So its prime factoration is 2 into 2 into 2 into 2 into 2 into 2. So that is equal to 2 power 6. Okay. So next n is equal to 4. 4 power 4. 4 power 4 means 4 into 4 into 4 into 4. 4 4 ja 16, 16 4 ja 64, 64 4 ja 256. So it is end with the digit 6. So its prime factoration is how much? 2 power 8. Okay, the number 4 power n is end with the digit 4 and 6. It is not end with the digit 0. So if a number is end with the digit 4 and 6, its prime factoration is only 2. Okay, so here the number 4 power n for all n belongs to n, capital N. N is the what? Natural number. Is end with the digit 0. Is ends with the digit 4 or 6. For any natural number, the number 4 power n is end with the digit 4 and 6. 4 or 6. Okay, and its prime factoration. And its prime factoration is only 2. Only 2. Okay. Its prime factoration is 2 power n. If the number 4 power n is end with the digit 0, ends with digit 0, its prime factoration is 2 and 5, but it is impossible. It is impossible. Why? The number 4 power n is end with the digit 4 and 6. Its prime factoration is 2 power n. If it is end with the digit 0, it is divisible by 2 and 5. It is multiples of 2 and 5. But here it is divisible by only 2. That's why it is impossible. Find the LCM and HCF of 6 and 20 by the prime factoration method. Prime factoration method means the number can be written as product of prime numbers. Prime factoration method or fundamental theorem of arithmetic. Okay, fundamental theorem of arithmetic or prime factoration means any natural number can be written as product of prime numbers. Okay, so here 6 and 20. 6 how we can write? 2 3 ja 3 1 ja. 6 divided with prime number. So 2 3 ja 3 1 ja. So the 6 we can write as 2 into 3. Next 20. 20 we can divide with prime number. 2 10 ja 2 5 ja 5 1 ja. So 20 we can write as 2 into 5. So what asking that? Find the LCM and HCF. LCM means what? Least common multiple. HCF means what? Highest common factor of 6 and 20 by using prime factoration method. So the 6 we can write as product of prime number, 20 we can write as product of prime number. Now take HCF. Okay, how we can take in prime factoration method? How we can take the HCF in prime factoration method means take the common multiple of two numbers prime factoration. 6 and 20. What is the common prime factor? 2. So 2 is HCF of 2 is HCF of 6 and 10. 6 and 20. Next LCM. LCM we can take in prime factoration the highest multiple of all factors. Okay, so here LCM is 2 here how many times multiple? 2 times, here 1 time. How many prime factors are there here? 3. What are there? 2, 3, 5. So 2 here 1 time, here 2 times. What are the highest multiple? 2 times. Next 3 here 1 time, here 0 time. So 3. Next 5 here 1 time, here no times. That is 5. So LCM how we can take in prime factoration of any two numbers or more than two numbers? The highest multiple of all prime factors. How many prime factors are there here? 3. What are there? 2, 3, 5. 2 here multiple 1 time, here 2 times. 3 here multiple 1 time, 5 is multiple 1 time. Okay, 2 2 ja 4, 4 3 ja 12, 12 5 ja 16. So 60 is LCM of 6 and 20. Find the SCF of 96 and 404 by the prime factorization method. Okay, so 96 we can write as prime factorization method. 2 4 ja, 2 8 ja, 2 24 ja, 2 12 ja, 2 6 ja, 2 3 ja. So 96 we can write as 2 into 2 into 2 into 2 into 2 into 3. Okay, next 404. 404 2 0 2. Next 2 1 0 1. We can write as 101 1. Okay, so here 404 we can write as 2 into 2 into 101. So here what asking that SCF, find SCF of 96 and 404 by the prime factorization method. So how we can take SCF in prime factorization method? The least common multiple factors, prime factors. Here what is the common multiple factors? 2. Here 2 how many times multiple? 5 times. Here how many times multiple? 2 times. So here what is the common? 2 times of 2 prime factors are common. That is 2 into 2. That is equal to how much? 4. So 4 is HCF of 96 and 404. Okay, here they ask me that find their LCM. Find their LCM. So here we know that LCM formula is, so LCM is equal product of two numbers by HCF. So product of two numbers here 96 into 404 by HCF how much? 4. Okay, 4 1 ja 4 101 ja is equal 96 into 101. Here that is here 96 0 0 96, that is 6 9 6 9. So LCM of 96 and 404 is how much? 9696. Find the SCF and LCM of 672 and 120 using the prime factorization method. So 6 how we can write? 2 3 ja 3 1 ja. So 6 we can write as 2 into 3. Next 72 we can write as 2 36 ja 2 18 ja 2 9 ja 3 3 ja 3 1 ja. So 72 we can write as 2 into 2 into 2 into 3 into 3. Next 120 how we can write? 2 60 ja 2 30 ja 2 15 ja 3 5 ja 5 1 ja. So 120 we can write as 2 into 2 into 2 into 3 into 5. So what asking that find the SCF. SCF means how we can take the common multiple factor. In these three numbers what are the common multiple factor? Here 2, here 2, here 2. 3 3 3. So what are the common multiple factors? 2 and 3. So here 2 next 3. So 2 into 3 that is how much? 6. So 6 is HCF of 6 72 120. LCM. LCM how we can find? LCM how we can take highest multiple of all factors. Here how many factors are there? 2 3 5. Here 2 is multiple how many times? 1 time. Here how many times? 3 times. Here how many times? 3 times. So LCM is, okay, what is the highest multiple of 2? 3 times. 2 into 2 into 2. Next 3 here how many times multiple? 2 times. Here how many times multiple? 1 time. Here how many times multiple? 1 time. What is the highest multiple? 2 times of 3. 3 into 3. Next 5 here 1 time. Here there is no time. 5. So 2 2 ja 4. 4 2 ja 8. 8 3 ja 24. 24 3 ja 72. 72 5 ja 360. So LCM of 6 72 120 is 360.